Okay, in this video we're going to review Unit 8 topics, and the first topic we will review is solving by factoring. I want to solve for x, which means I want to know what value of x will make this equation true. And we go through the factoring algorithm, which means I first look for a greatest common factor. So the first step, look for a greatest common factor. All right, and so in this case, is there a greatest common factor? There is. 6 can divide everything, and so can x. And what I do is I divide by 6x on every term, and then whatever's left is inside the parentheses. Now that 6x doesn't just go away when I take it out, it goes on the side like this. 6 divided by 6 is 1, x squared divided by x is just x. Negative 18 divided by 6 is positive 3, x divided by x is just 1. So I have 6x times x plus 3 equals 0. Now by the zero product property, once I've finished factoring and I have two factors, 6x and x plus 3, and they're both being multiplied together to equal 0. And by the zero product property, I know that either 6x has to be 0 or x plus 3 has to be equal to 0. And the zero product property just says that when I multiply two things together to get 0, then one thing or the other thing has to be 0. I divide by 6 on the left side, so x has to be 0. Or if I subtract 3 on the right side over here, I get x equals negative 3. So it's going to be one or the other. It can't be both at the same time. X is either 0 or negative 3. And when I plug those values back in for x into this equation, it should get 0 on the left side to make the equation true. Now, of course, all the factoring things we're doing here don't make any sense if the side of the equation is not equal to 0. So on the second example, the first thing I need to do is subtract 7 from both sides. 2x squared minus 13x minus 7. So if it's one of the sides isn't 0, you want to make sure that you make it 0. And now I continue the factoring algorithm. I look for a greatest common factor. There is none. Are there perfect squares in the front and the back term? There are not any perfect squares. So then what I can do is just factor by guessing and checking. Now the nice thing, you see I've already written a 2 in there, and that's because I know that 2x squared, that expression, that term is prime, which means that there's only one option, 2 times 1. And of course I have to have x times x to get the x squared. Now, on the right side, we're lucky again because the negative 7 only has one possibility. Actually, I guess two, negative 1 and positive 7, or positive 1 and negative 7. So I need to kind of guess and check to make sure this works. So I'm going to first start by putting negative 1 and positive 7 and see if that works. So I check by multiplying the inner product, negative 1x, and the outer product, 2x times 7, to get 14x. And if I add the middle product and the outer product, I get positive 13x, which is close, but you'll notice that I need a negative 13. So this is an easy fix. If I get the right number with the wrong sign, all I know is that my signs need to change. So instead of being positive 1, I have a negative, instead of having a negative 1, I have a positive 1 and a negative 7. Okay, and so now I will use the zero product property, which states that if I have two things multiplied to be 0, then one of them has to be 0 or the other one. So 2x plus 1 equals 0, or x minus 7 equals 0. So I solve by subtracting 1 on the left factor. I get 2x equals negative 1. I divide by 2, and so x equals negative 1 over 2. All right, and that's one of my options. Or if I add 7 to both sides of the other expression, the other factor, I get x equals 7. So x equals 7 or x equals negative 1/2. Those are my two options. And the very last one, you notice that I don't have it set equal to 0. Y equals 3x squared plus 7x plus 2, so I make this y into a 0, and now I can solve by factoring. Again, this really is important that you set one side of the equation equal to 0 before you start factoring. Is there a greatest common factor? Nope. Is there a special case? Nope. So guess and check. Lucky, the first and the last terms are prime. 3x and x is my only option. And since it's positive 2 here and positive 7, they have to add to be positive 7 and multiply to be positive 2. So I only have one option, 1 and 2. Let's just try it this way. And you'll see that I made a mistake because now 2x and 3x will only make 5x, and that's not good. I need to get 7x. So then if they don't get the right number, then we know that we need to get the numbers switched around. Now, don't give up if you don't get in the first 2 tries. You might just be not doing the right factors. So just go ahead and keep trying. Don't give up. There's none on the test that will have no answer. So in this case, I set the first factor. Since it's set equal to 0, I can take each factor and set that factor equal to 0. Subtract 1, 3x equals negative 1. So now I have looks like x equals -1/3. On this one, I have x plus 2 equals 0. Subtract 2, then x equals -2. Those are my two options for x. The next part of Unit 8 that we want to review is how to graph. The first thing we check when we're graphing is which way it will open. This one will open up because the leading coefficient, +2, is positive. Now to check whether it's wide or narrow, you want to see if it's close to 0 or far away from 0. So if this is 0, anything that's between -1 and +1, that's going to be wide in this area here. So between these two, -1 and +1, it's going to be wide, and on the outside of that, it's going to be narrow. Now you can see very easily that +2 is in the narrow region. It's going to be over here somewhere. So it's going to be up and be narrow. All right, the next thing we want to do is find the zeros, or the x-intercepts, or the solutions, or the roots, whatever you want to call them. In order to find those, I have to set the y equal to 0. So I'm going to do that quickly. I'm going to set the f of x equal to 0, and now I have 2x squared minus 7x plus 3. I'm not going to go over how to factor this because we just got over how to factor, so I'm just going to quick factor it here for you. I know I need to multiply by -3, so I need -3 and then -1. So I have -1x, -6x, and that makes -7x. So we're good to go. So by the zero product property now, I could set each of those factors equal to 0. I don't know why my head isn't showing up there. Let's try it again. There we go. 2x minus 1 equals 0. So x equals +1/2. I didn't show the math there, but you should be doing the math yourself, and x equals +3. So those are my two x values. If I write the zeros, I'm going to write them as ordered pairs, and so it's going to be +1/2, 0, and +3, 0. Now to find the axis of symmetry, I need to find the middle between those two values. So I'm going to have 1/2 plus 3 divided by 2. And then in that case, I have 3.5 divided by 2. Now use a calculator for that, and you're going to get 1.75 as my x value. So the axis of symmetry is a vertical line. It should be x equals 1.75. Excellent. Okay, now what I want to do is I want to find the vertex. Now the vertex is going to be on the axis of symmetry, so I know that the x value of the vertex has to be 1.75. To find the y value, I must plug it into the equation for x into the factored form of the equation. So y equals, and it's going to be 1.75. Oops, I forgot the 2. I'm plugging it into this expression here. So that's 2 times x, which is 1.75. I'm going to subtract 1. And the other factor, I have 1.75. I'm going to subtract 3. So I'll go ahead and do that. So 2.75 times, or 1.75 times 2 rather, is 3.5 minus 1. Oops, there you go. And then 1.75 minus 3 is -1.25. Now if you don't understand how I'm getting it, I'm just using a calculator to get those. Okay, so then you could just multiply. It's going to be 2.5 times -1.25. Again, I'm just using a calculator off the screen here. It's going to be -3.125. So you'll be using a calculator to do this math. Now, -3.125 is -3 1/8, in case you were wondering. So now I have to start the process of graphing this. I have a couple points already. I have 1/2, 0, 3, 0, 1.75, -3.125. Now, to find another, well, actually, just go ahead and graph these points first. I have a lot of fractions in here, so I'm actually going to make my scale go every other box as a unit. So every one line is going to be 1/2 of a unit. And you'll see why. It makes it fit a lot nicer on the screen here. So I'm just going to label all these. It's -1, -2, -3, and I go the same on the upward side, positive side. All right, let's plot the points now. I want to make them stick out nice and bright, so I'm going to go ahead and use pink. So I have +1/2 is the first x-intercept, which if you notice my scale, every line is 1/2, so there's 1/2, 0. Now 3, 0 is going to go over here. The axis of symmetry is going to be at 1.75. There's 1, 1.5, and 1.75 is between 1.5 and 2. So here's my axis of symmetry at 1.75. 1.75 -3.125 is right there. There's my vertex. I'm just kind of guessing here. Now I almost am done. I need one more point to plug in. So I'm going to plug in an x value that's between 1/2 and 3. So I'm going to use +1. If I plug +1 in the equation for x here, I'm going to do it over here. It's 2 times 1 minus 1, and I have 1 minus 3. And so I'm going to get 2 minus 1, which is 1. 1 minus 3, which is negative 2. So when I plug in 1, I get negative 2 out for y. So 1, negative 2 will go here. And because of the axis of symmetry, if I go 0.75 over, that's 2.5, I will also get negative 2. There you have it. Graph the parabola nicely. Try to make it a nice U shape here, not a big V. And there you're done. We have 2 more parts of this video before we're finished here. Now my task is to write the equation of a function that is less steep, which in other words, right, make it wider. And I want it to open in the opposite direction and have 2 roots in common with, which means same. So same roots, roots the same, which means the x-intercepts have to be the same. So if I want this to be wider, and right now it's 3, if I look at a number line, 0, 1, in order to get wider, I need to get closer to 0. So if 3 is over here, I just need a number that's going to be closer to 0 than 3. Now because it opens in the opposite direction, it's going to be a negative number. So I need a negative number that's closer to 0 than negative 3. So you could choose maybe negative 2 or negative 1 or negative 0.5, it doesn't matter. Now for the factored form, they have to have the same x-intercepts. So to get the same x-intercepts, the factors have to be the same. Because remember, to get the x-intercepts, I let the factors equal 0. So if I want the same factors, or the same roots, I want the same factors. And there, I'm done. And there's several different correct answers for this one, depending on what you chose for A. And the last thing we're going to do on this Unit 8 review is to write the equation of the function that's graphed over here. So the first thing I need to do is realize that this is going to be in a special format. It's going to be a times x minus something and x minus something again. Now, the something that you're going to minus inside are going to be whatever the x-intercepts are. So in this case, my x-intercept is going to be negative 1. So one of the things I'm going to subtract is negative 1. And the other x-intercept is positive 3. So I'm going to subtract a positive 3. And now I have y equals a times x minus a negative 1. This is a big trouble area for a lot of you. Minus a negative makes a positive. Add the opposite. X minus 3, that stays a minus right here. And I'm almost done. The last thing I need to find out is what this a value is, right down here. To find the a value, I have to plug in another point into the equation with an x and a y. Now there's 3 points that I would say are good candidates or good options here. You have the vertex, which is at the point 1, 8. And remember, the ordered pair is going to be x comma y. The other point I could use maybe is 2 comma 6. 2 for x, y is 6. And finally, what I think is the best option is this one, 0 comma 6, the y-intercept, because you have x is 0. So I'm going to use that one. I'm going to plug it in for x and for y. Notice every time I see an x, I'm putting in 0. Every time I saw a y, I'm putting in 6. And I just solve for a. You see I'm just adding and multiplying and dividing. What is a? Negative 2. We put this all together and we have the equation of the graph, y equals negative 2 times x plus 1, x minus 3. And that's all we have for this video.